the number of workplace injuries N occurring in a factory on any given day is Poisson with mean lambda. The parameter lambda is a random variable that is determined by the level of activity in the factory and is uniformly distributed on 0, 3. Find variance of N. Now, the first reaction of some students here might be that, okay, N is Poisson with mean lambda, and we know that for a Poisson, mean and variance are equal. So why isn't the answer just lambda? Because lambda is the mean, so the variance should also be lambda. Now that's fine, but since here we are given some more information about lambda, actually we can use that information to find a numerical value of lambda. Therefore, A is not the right choice. We have enough information to actually see what the numerical value of lambda will be. Okay. So for this, we will use a very rarely used formula. And the formula is that variance of any variable. So if any random variable, if lambda is the mean of that variable, then the variance of that random variable will be expected value of variance of n given the mean plus variance of expected value of n given the mean. Okay, so basically you just interchange expected value and variance, and it's n given the mean of n. And let's see how these things will be. So first let's look at this one, the expected value of n given lambda. So we are saying that the expected value of n, which is Poisson, given that the mean is lambda, and we know that that's just lambda because that's just a roundabout way of saying that the expected value of Poisson of mean lambda, which is just lambda. And the second thing, variance of n given lambda is again the variance of the Poisson distribution whose mean is lambda, and we know that the variance of Poisson equals the mean, so that thing will also be lambda. So both these things, the variance n given lambda, that's lambda, because Poisson mean and variance are the same, and the expected n given lambda is also lambda. So this equation then becomes variance n equals expected value of lambda plus variance of lambda. But now we use the fact that lambda is uniform 0, 3. That's what they tell us. Yeah, lambda is distributed uniform 0, 3. Okay. And we know that for a uniform AB distribution, the mean or the expected value is a plus b by 2. So here it will be 0 plus 3 by 2 equals 1.5. And the variance of uniform is b minus a squared by 12. So 3 minus 0 squared by 12. That's 0.75. So now substitute these two values in this equation, get 1.5 plus 0.75. And that is 2.25, which is choice E.